Welcome back to our tensile testing series. In this video, I am going to provide you with all the tools and the information you need in order to determine the percentage elongation from stress strain data. The percentage elongation is a measure of ductility of a material. By definition, percentage elongation tells us the amount a material stretches before it actually fractures. A material with larger percentage elongation basically means that it can undergo a lot more plastic deformation before it fails. And at first, it seems very easy. If our data set already contains strain, one might think that we'll simply take the last value of the strain from the stress strain data and multiply it by 100 to get the percentage elongation. But as always, the reality isn't that simple. After a specimen fractures, the tensile machine itself doesn't stop recording immediately. The grips or the jaws may continue to move for a short period of time. The broken halves might slip slightly, or the machine may continue logging the data before the operator stops it. As a result, you may have several additional data points with a really low stress value and the strain increasing during those data points. So if we simply take the last data point from the measured data, we might end up overestimating the ductility of the material or the percentage elongation in this case. So the first method that I'm going to show you is the naive approach, where we just take the last data point. So as you can see, in this approach, we end up with the wrong results. So a better approach is to actually identify the actual first fracture point, where the material first loses its load carrying capability. Once we locate the point, we can simply multiply that strain value by 100 to get the percentage elongation of this material. Now there's one other aspect. According to standards, once the material breaks or fractures, the two broken halves are fitted carefully together and the final gauge length is measured manually. And using that value, the percentage elongation is calculated by final gauge length minus the original gauge length over the original gauge length times 100. When the engineering strain is calculated correctly, both of these approach, the second one and using the final manual method of putting the two broken samples together, should give us similar results. So now you know how to determine the percentage elongation from the stress strain data. Feel free to leave your questions or suggestions through the comments or through any of the Google links provided in the description of the video. And if you ever need any of the codes that I have used so far, just let me know through comments or through any of the Google form links as well. Don't forget that you still have the chance to win prizes through the Matty Meme Challenge. And as always, I'll see you guys in the next one.